It's in the review packet, the smaller of the two packets. It's not in that one. It's in the review packet. Your review packet has 4 pages to it. And coincidentally, those are the 4 things that you are going to do and turn in on test day. When is your test day?
Monday.
Monday, right, okay. So, here we go. We are on review sheet 2. On this particular sheet, I circled the ones that you're allowed to use a calculator on. So let's go through and do all the ones that we're not allowed a calculator, because that's the way your test will be. They'll all be grouped together. So here we go. Number 1 says, it doesn't have any directions, but we're supposed to figure out what this is. We want to figure out what is the value of this thing. Okay? So how do we do that? Well, you should know this by now. How do we do that?
6.
Yep, we can't solve a logarithmic equation when it is a base 6. So you got to get rid of the base 6. Okay, 6 to the x equals 13. Now look where the exponent, or where the variable is. The variable is an exponent. Whenever the variable is an exponent, you're going to need logarithms to solve the equation. All right, let me say that again. Whenever the variable is an exponent, you're going to need logarithms. Unless you can somehow get a common base, you're going to need logarithms. So I'm going to take the log of both sides. Now, why do I do that? Why do I take the logarithm of both sides? Because now the x becomes a coefficient. So x log 6 equals log 13, and the answer is log 13 over log 6. Now, if I don't have a calculator, oh, I do. Shoot, that's circled. Darn. Okay, well, we're doing the calculator. So now we type that in on our calculator. So much for doing all the no calculators first. That's all right. So it's log 13 divided by log 6. Make sure you type it in right. You should get something that is about 1.43.
Is this one where you got to put log for both?
Huh?
For both, you got to put log for both. 13 and 6, right?
Is this what you mean?
Yeah.
Yes. Yes.
On the test, will you tell us what decimal place you want us to
Yes.
round it to?
Yes. Yes. All right, let's skip down. Let's do all the calculator ones. Oh, we don't need to do that. Let's keep them in order. Number 2, here we go. This is another logarithmic equation, but I'm not going to use a calculator on this one. I'm going to do this one all by myself. So, any ideas?
What did you do? 2 to the 5th?
Well, you can't do anything until you deal with this.
Yeah, so do you
So there are 2 ways to deal with that. One way is to do the opposite of what we did over here. Where did this coefficient come from? It was an exponent. So you could put this up here as an exponent. That's not my favorite thing. My favorite thing is to just divide it out, get rid of it altogether. So I don't even have to worry about it. That's my favorite thing to do. You can't do anything until you deal with that 3 one way or another. Now, Brenton, I love your suggestion. Your suggestion is 2 to the 5/3 equals x minus 1. 2 to the 5/3 equals x minus 1. Now, this is not anything, I mean, it's not like I can say, okay, that's 16 or something like that. I can't do that. It just stays 2 to the 5/3. If that bothers you, you can think of that as what? What's another way of thinking of 2 to the 5/3? The cube root of 2 to the 5th. And if you want to think about it like that, it's fine. It makes 0 difference. I am perfectly comfortable with 2 to the 5/3. If you want to write it as a radical, that's fine. You have to add 1, and that is the value of x.
So you can leave it like that?
Yep, you have to. I mean, there's nothing to do. You could get a decimal on your calculator, but since it's a no calculator problem, we're just going to stop there. figure out what this equals. This is another little equation. We're gonna figure it out. This one's a little bit more special though. You should immediately recognize you got a 7 and a 49. That means something is gonna happen, right? What's step 1? Radicals do not live in logarithm land. You don't want to have a logarithm and a radical in the same expression.
So what did you do? 49.
So you're going to think of that as 49 to the 1/4. That's the first thing you want to do. Think of it as 49 to the 1/4.
Change up this 7.
At this point, you've got two options. I'll go ahead and write them both down. From now on, I'm not going to do that. You'll have to pick one or the other, whatever flips your switch. But one option would be to take that 49 and write it as 7 squared. It is. That's what 49 is. It's 7 squared.
Wouldn't it be easier?
So you have, now just wait, easier is a relative term. We're showing both ways. So we have the log base 7 of 7 to the 1/2. So the answer is 1/2. Now, Brenton says, go back to this step right here. Brenton says, I'd rather just rewrite it as an exponent like this. So 7 to what power? 7 to the x equals 49 to the 1/4. Then you have to do basically the same thing. 7 to the x equals 7 squared to the 1/4. Can you see how x is going to equal 1/2 that way too? So again, it makes totally no difference which way you do it. It's just however it makes sense to you, that's how you're going to want to do it. Number 4, you don't even have to show any work for number 4. What's the answer to number 4? 3. That's one of your properties. The answer is 3, period. Number 5. You can't do anything until you take care of 2 logarithms. You can't have 2 logarithms on the same side of an equation. So you have to put them together. All right? They got to go together. We're going to write this as 1 logarithm. Now, what's going to go in here? How are those going to go together? I'll give you a hint. They always go together as either a multiplication or a division. How are these going to go together?
They divide.
There's going to be a divided by. And the reason it's a division is because that is a subtraction. If that had been an addition, they would go together as a times problem. So I've got x minus 2 over 5. You must put the logarithms together. You can only have one on a side. Now what? As soon as you get one on a side, then what are you thinking? 6 to the second equals x minus 2 over 5. That is how you solve logarithmic equations that have logarithms on just one side. You have to translate them. You have to. 6 to the second equals that. So 36 equals x minus 2 over 5. 180 is x minus 2, so it looks like the answer is 182. Number 6, how long does it take to triple an investment at 3.4% compounded annually? Okay, all of these word problems, you have 4 formulas, right? And 2 of them have to be memorized and 2 of them will be provided, right? Remember this? Okay, so the 2 that are provided are the future value and present value formulas. And when you read a problem, what word pops out at you so you know you're going to use either FV or PV? The book formulas. There's one word that's going to pop out. What? Sort of. The word payment is in there. You're making payments. So you can be making payments contributing into an IRA or something like that. or you can be making contributions to your car loan, paying off your car loan. If you are making regular payments, usually monthly, but they don't have to be, if you're making regular payments, you're going to use one of the book formulas. Is that what's happening in this problem? Are we making regular payments into an account in this problem? No. So we're not, because it's not a hard question. You are not making payments in this problem. You're sticking some money in and saying, how long does it take for it to triple in value? So we're not using one of the book formulas, which means we're using one of the formulas that we have memorized. Either this one or this one. All right, so which one is it? How do we know which one of these formulas is the one we want to use in this problem? What's the difference? How do we know? Uh-oh. Max?
Because it says it wants to triple in investment, wouldn't it just be
Both of these formulas will triple an investment.
But didn't you say that one of them would be only considered for like financially?
Both of them can be used for money. Both of them can be used for money. Now, this one is only used for money, but this one can also be used for money. So how do I know which one I'm using? The word compounded. The word compounded. If it says compounded continuously, if the word continuous is in there, you're going to use this one. This doesn't say compounded continuously. What does this one say? Compounded annually. That means one time a year. Okay, so now I'm going to use this formula. I've got it narrowed down. I'm going to use this formula, and I'm going to start putting stuff in. So what goes where? Get your notes out from the video. I'm not reteaching it. If we have notes, great. If we don't, I'm not doing it. I'll skip it and move on.
3 equals 1.
Okay, and it wouldn't have to be 3 and 1, but it has to be, you have to end with 3 times whatever you started with. So 3 and 1 are good choices. Good choices. But you could use 30 and 10 or 300 and 100 or whatever numbers you wanted. You just have to end up with 3 times what you started with. Okay, good start. Good. Okay, now what?
So she put 3.4.
I don't put in 3.4. I put in what? 0.034. I gotta put in the decimal. All of the formulas require a decimal, not a percentage, okay? So there's your interest rate, 3.4%, 0.034.
Is it over 1 simultaneously?
Exactly. Somebody watched your video and a bunch of you didn't, which is very disappointing. Makes me very angry, actually. So N is 1, and then T's what I don't know. How long is it going to take me? All right, now pay attention. The variable is an exponent. That means at some point I'm going to need logarithms. Now, not right away. The first step is divide by this number. Now, since it's a 1, that's easy. But now I need logarithms. I'm going to take the logarithm of both sides. And why am I doing that? Why am I cluttering up my problem with logarithms? Because now the t comes out front. It's the only way to solve for t, guys. Unless you want to do a bunch of trial and error, you're not going to be able to find t without pulling it off. And the only way to pull it off is to take the logarithm of it. So we've got our logarithm, both sides. So we'll type in the log of 3 divided by the log of 1.034. And that works out to be what? 32.86. So it's going to take about 32.86 years to triple your investment. Number 7, easy problem. No work necessary for number 7. What's the answer? 2. Remember, an ln and an e back to back always cancel out, right? Always cancel out. So that just says x equals 2. Alright, so now we've got another equation to solve. We have the same issue we had before. You can't have 2 logarithms on the same side. They have to be put together. These have to be condensed into one logarithm. How will they be put together this time? As a multiplication. So 18x minus 3 is what we're going to have in there. We're going to multiply those together because the logarithms were added. Now, ln this equals ln this. So the ln's are gone, and these two things equal each other. 18x minus 3 equals 9. So 18x equals 12, and x equals what? 2/3? And we're done. Number 9 says write the equation of the exponential function. All right, so what does that mean it's going to look like? Exponential function. Y equals a times b to the x. That's what I'm shooting for right there. Y equals a times b to the x. And I know that I have the point 0, 2 and the point -1, 6. All right, so how do I start?
Use the 0.
Use the one with the 0 first, plug in x and y. So 2 equals a times b to the 0. So basically 2 equals a. We call that our initial value. Initial value is always 0, comma. So now your equation looks like y equals 2 b to the x. Because you know a is 2. Alright, so then what? So then we put in our other point. So 6 equals 2 times b to the -1st. How do you solve that? Divide by 2. So 3 equals b to the -1st. So what? So one strategy is say, okay, that means 3 equals 1 over b, because b to the -1st means 1 over. So 3b equals 1 and b equals 1/3. Now some of you are going to be able to go straight from here to here, and that's okay. If b to the -1st is 3, then doesn't it make sense b would be 1/3? If that makes sense to you, great. You can go straight here. If not, then go through the steps and you'll get the right answer. Oh, don't forget to write the answer, by the way. So the answer would be y equals 2 times 1/3 to the x, because your job was to write the equation. So we want to make sure we remember to do that. All right, number 10, population increases from this to this in this many hours. By what % does it increase each hour? Okay, so it's another word problem. All right, so I've got 4 formulas. So is this problem going to be, this problem right here we're going to do, is it going to be one of the ones in the book? One of the given formulas? No, it doesn't even have anything to do with money, right? There's no payments being made, so it's not those, it's one of these. It's the one on the right, because this one is only used for money. All 4 of the formulas can be used in money problems. The 2 in the book and this one are only used for money problems. So if it's not a money problem, it's going to be this formula. It's only one up, that's an option. All right, so what goes where? So using this formula. So what goes where?
A is the ending value.
So that would be 98765 equals
1, 2, 3, 4.
1, 2, 3, 4.
E, and then R is what you're trying to find.
R is what I'm looking for. I do not know what R is.
And then T is 77.6.
And T is 77.6.
You just do a straight up divide.
Now, where's your variable? Exponent.
Oh, you have to,
At some point, I'm going to use logarithms. And since it's an E, I'm probably going to ln both sides, but not until I do what? Something has to happen first. You have to divide. So 98765 over 1, 2, 3, 4. Unless that goes in evenly, I don't want you dividing it. I don't want any round off error in there. Just leave the fraction. Leave the fraction. Now we can take the logarithm of both sides. And if you want to log, that's fine. I'm going to ln both sides. And again, the only reason I'm doing this is because it's going to allow me to pull that exponent off, right? And in fact, what happens every time you have an ln and an e back to back? They cancel. So the log of 98765 over 1, 2, 3, 4 equals 77.6R. So what am I going to type into my calculator? ln 98765 divided by 1, 2, 3, 4 divided by 77.6. And I got an R value of about 0.0565. Now let's make sure we answer the question. By what percent does it increase each hour? So about 5.65% each hour. All right, 11 is another word problem. All right, so the first thing you have to decide is which formula you're using. So tell me, which one am I using?
because the end is also compounded.
So I'm using this one right here.
Yeah.
Okay, there's the same thing about payments, so I'm not messing with those. It's this one right here. So find the interest rate compounded quarterly if 321 grows to 987 in 11 years. Okay? So what goes where? That's the formula we're using. We decided that.
So A is equal to 320.
It'd be 987.
So 987 equals 321, 1 plus. R, don't know R, over 4, compounded quarterly, to the 44th power, 4 times 11, yep. Now, where's your variable?
It's in the
Not an exponent. So guess what? No logarithms. We're not going to be using logarithms to solve this, and we're definitely going to need a calculator, but we're not going to use logarithms. Step 1's the same though. What's step 1 going to be? Divide. You've got to divide. Okay, so that's step 1's done. You always divide. Do not take the logarithm of both sides though. That will just make the problem harder. We only want to use logarithms when our exponent is the variable, and it isn't this time. However, do I still want to get rid of that exponent?
yes.
Yeah, if I'm going to try to figure out what R is, I have to get rid of the 44.
You just
So-
square root cube.
So what'd you say?
Square root.
Well, not square root it, but 44th root it.
Yeah.
So I'm going to 44th root both sides of the problem, and that will get rid of that, right? And leave me with this. Now, I actually can do a 44th root on my calculator, but I find it a hassle personally. So instead of taking the 44th root, I'm going to raise this to what power? The 1/44th, right. So I'm going to take that number, raise it to the 1/44th, 987 divided by 321. Oop. 987 divided by 321. Then I'm going to raise it to the parentheses, 1 divided by 44 power. Make sure that's in parentheses, 1 divided by 44. Did you get 1.025 stuff there?
Yeah.
Okay, now, remember, you're solving for R, so now we'll take the number on our calculator and minus 1, and then times 4. And the answer is about 0.1034. So it said find the interest rate, so we need about 10.34%. All right, number 12. LNs and E's cancel each other out if they're back to back, right? So let's get them back to back. What are we going to do at that fifth root? It's e to the fourth to the 1/5, right? Which is ln e to the 4/5, which is just 4/5. The answer is 4/5. Easy. 13, how are you going to figure that one out? X to the 4th equals 3, which means x equals what we did over there. 3 to the 1/4, the 4th root of 3 or 3 to the 1/4, whichever you prefer, they're the same thing. You're going to take the 4th root of both sides in order to solve that equation. Just like here, you took the 44th root, here you're taking the 4th root of both sides. And it's a no calculator problem, so you're just going to leave it as either the 4th root of 3 or 3 to the 1/4. Write the equation of the asymptote of y equals 2 to the x plus 4. 2 to the x plus 4. And state the range. Okay, well forget this for a moment. What does that look like? Y equals 2 to the x.
Exponential.
It's an exponential. What's an exponential look like? Has an asymptote right here and looks like this. That's the 0.01. Okay, how do we know that? So BFF. Now, what's plus 4 do to that? It's going to take that picture and move it up 4. So this asymptote was at y equals 0. Well, now that asymptote's going to be clear up here at y equals 4. And the point is going to be 0, 5. But it's going to be exactly the same picture. So what is the question again? Write the equation of the asymptote. I already did that. And then what's my range? Y is greater than 4. Or if you want to look like a real mathematician, you could say 4 to infinity would be your range. All right. 15. If the log is no log, find a log. Okay. This is using our properties. Let's see what we can do here. So we're going to find the log of 20x cubed. Okay, now, looking at the given that they've given me, which are the log of 2 and the log of 5, I'm going to have to break this 20 down. luckily, how can 20 be broken down? Well, think of, what are its factors?
5 and 4 and 5.
4 and 5, or 2, 2 and 5, if we went all the way down. So we could think of this as the log of 2 times 2 times 5, and then x cubed. Now, these are all being multiplied. So I'm going to pull my problem apart, kind of the opposite of what I did earlier when I put it together. I'm going to pull it apart. So this is going to be the log of 2 plus the log of another 2 plus the log of 5 plus the log of x cubed. So instead of putting them all together so I only have one logarithm, I'm taking them apart, and I actually now have 4 logarithms. And why are there plus signs between them? Because when you take apart a multiplication, you add them. When you put together, like if I put all this back together, do you see how that would all become 2 times 2 times 5 times x cubed? Because they're being added. When you put them together, they become a multiplication. When you take them apart, they become an addition. Now, that was given to me. This number is 0.1112, and so is this one, and that one is 0.2121. And what's the log base x of x cubed? 3. So the answer is just whatever all that arithmetic is. I got 3.4345. Hopefully I had it right since I did it on my calculator. Is that right? So what was the key to doing that problem? Breaking that down. Breaking it all the way down, as far down as you could get it. 16, write the equation of the logistic function. All right, what is that going to look like? You can't even begin the problem if you don't know what you're shooting for. What is your equation going to look like? Y equals A over 1 plus BC to the x, right? So here we go. The limit to growth is 100. Stop right there. What are you going to do with the limit to growth? That goes right here. That's 100. No work, just stick it in. The initial value is 20. The initial value corresponds to a point. The initial value is not a number in the equation. Now it is in an exponential equation, but not in a logistic function. The initial value is a point. What point is represented by an initial value of 20? 0, 20. Your initial value is always your y-intercept. Is always 0, comma. So I can take that point and put it into my equation, and that should allow me to solve for something. I should be able to figure something out from that. What is c to the 0? 1. So this is going to allow me to figure out b, isn't it? So what do? Distribute the 1 plus b, so I have 20 plus 20b equals 100, so 20b equals 80. It looks like b is 4. So now my equation looks like y equals 100 over 1 plus 4c to the x. And then what's left? Something should be left. I have the point 2 comma 50. So now I'll plug that in. So I should be able to figure out what C is now. So what will I do? multiply to clear the fraction, distribute. I'm going to distribute again. So I'll have 50, not 500, 50 plus 200c squared equals 100. So 200c squared equals 50, and c squared equals 1/4, which means c equals 1/2 the square root of 4. So my answer, don't forget you have to write the equation, is 100 over 1 plus 4 times 1/2 to the x. And the 4 and the 1/2 are separate numbers. Do not put them together. Leave them separated. They are separate numbers. There's your logistic function. Okay? Compare y equals 4 to the x with y equals 4 to the negative x. Well, again, this should be simple for you. What's the relationship between these two equations?
You got x.
What?
You have x.
Yeah, and what happens, you know what this one looks like. This is your exponential. I've already drawn it once today. It looks like this. What happens when I change the sign on x? Flips it this way. Katie says this way. So that's going to look like this. So the question says, compare them, which represents growth, which represents decay. This one, 4 to the x, is growth, 4 to the negative x is decay. And that should make sense to you, because what's another way of writing 4 to the negative x? 1/4 to the x. And when you multiply by 1/4, do your numbers get bigger or smaller if you take it times a 4? They get smaller. It makes sense that would be decay. When you multiply by 4, your numbers get bigger. So it makes sense that would be growth. Right? Okay, is it time to go? Is that why you're all happy now? Okay, so remember we got to 17. Alrighty, I'll see you tomorrow, I know. Oh Lord, I know. Yay, we have class tomorrow. Oh my gosh, I get to see you 3 days in a row.